Divide the coefficient of x by 2. Square the result. And write the quadratic. Which is now a trinomial. And the square has been completed. We will now solve quadratics by completing the square. For example, x squared plus 10x minus 24 equals 0. Take the absolute term from the left-hand side and place it on the right. Complete the square on the left-hand side. Half of 10 is 5, and 5 squared is 25. We therefore have x squared plus 10x plus 25 is equal to 24 plus 25, which can be simplified to 49. What we have here then is that x squared plus 10x plus 25 equals 49. If the square root of both sides is taken, you will still have a balanced equation, and this operation will result in a linear equation of one variable on the left side, which can easily be solved. Continuing with this operation then, the square root of x squared plus 10x plus 25 is x plus 5. And on the right side, the square root of 49 is plus or minus 7. Continue and solve for x. First, choose the plus 7. If we take plus 7, then x plus 5 equals plus 7, and x will equal to 2. Or, on the other hand, if you choose the minus 7, therefore, x is equal to minus 12. If you use the method of factoring on this trinomial, and it is factorable, you will get the same results. Here is another example. X squared minus 10x plus 24 equals 0. Take the absolute term and place it on the right-hand side, then x squared minus 10x equals minus 24. Add to the left side, an amount which makes the left side a perfect square. Half of minus 10 is minus 5, and minus 5 squared is positive 25. So x squared minus 10x plus 25 is equal to 25 minus 24, which in turn is equal to 1. Taking the square root of both sides, the left side is x minus 5. And the right-hand side is plus or minus 1. Therefore, choosing the positive 1 first and solving for x, x is equal to 6. Choosing the right-hand side as minus 1, x will equal to positive 4. Here is another example. 2x squared minus 6x minus 3 is equal to 0. Begin first by establishing expression, the trinomial, with its coefficient, the leading coefficient, equal to 1. To establish that, you simply have to divide through the equation by 2. If you divide by 2 in the first step, you get x squared minus 3x minus 3 over 2 equal to 0. Take the constant here and place it on the right-hand side, because this is not a perfect square. We end up getting x squared minus 3x equal to positive 3/2. Instead of taking a new line, as I did in the previous examples, I'm going to fill in this blank simply and save writing an extra line. Half of minus 3 is minus 3/2, and minus 3/2 squared is positive 9/4. On both sides. With a common denominator 4, the sum of these fractions is equal to 6 plus 9 is 15. 15/4 is on the right-hand side. Taking the square root of both sides, the left side will be equal to x minus 3/2 equals plus or minus the square root of 15/4. Simplifying right-hand side, since the square root of 4 can be taken, we can write this as a mixed radical plus or minus the square root of 15 over 2, or if you like, plus or minus 1/2 the square root of 15. Either way is acceptable. Therefore, x is equal to, using the positive sign first, x is equal to 3/2 positive the square root of 15/2, or 3 plus the square root of 15 all over 2. Using the calculator, we can establish the approximate value for this, since the square root, the fraction is irrational. 3.4365, writing the answer to 4 decimal places. On the other hand, x can also equal 3/2 minus the square root of 15 over 2, using the negative signed result on the right side, which becomes 3 minus the square root of 15 over 2. And as a decimal, we can also work this out, 0.4365. The last method will be by formula. We will begin with the quadratic equation in standard form. Prepare the equation in order that the method of completing the square can be applied. In other words, because the leading coefficient is not equal to 1, we must arrange for it to equal 1. Equal 1, we will simply have to divide by a. Dividing by a, we end up with 1x squared plus b divided by ax plus c divided by a equals 0. Since the left-hand side is not a complete square, take the constant c over a and place it on the right. So x squared plus b over ax is equal to negative c over a. Complete the square on the left by taking half of the coefficient of x, which is b divided by 2a. And b divided by 2a quantity squared is b squared over 4a squared. And add that amount to both sides. These two fractions on the right should be added. On the right, the common factor will be 4a squared. 4a will have to be multiplied by minus c. And we'll end up with b squared minus 4ac. Taking the square root of both sides, the result is x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. 4a squared in the denominator is a perfect square. So we can rewrite this result on the right as a mixed radical. This is equal to plus or minus the square root of b squared minus 4ac divided by 2a. Now, to solve for x, taking the constant b over 2a on the other side of the equal sign, the result is x equals minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. We often write the formula for the value of x as minus b plus or minus the square root of b squared minus 4ac all over 2a, written only once. So here you have the formula, and it is known as the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac, all of which is over the 2a. You must memorize this formula. Here are some examples. 3x squared plus 7x equals 11. The first step is to write this as a quadratic equation, which would be 3x squared plus 7x minus 11 equals 0. Now let's rewrite this in the following way using some color. 3 plus 7 minus 11 equals 0. There's x and there's x squared. Compare it to the quadratic equation in standard form. Ax squared plus bx plus c equals 0. A is 3, b is plus 7, and c is minus 11. In the formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, all of it is on 2a. If b is plus 7, then minus b is minus 7. Plus or minus the square root of b squared is 49, minus 4 times 3, which is 12, times minus 11. That's positive 132. And all of this is upon twice a, twice 3, which is 6. Minus 7 plus or minus the square root of 181 over 6. So you have two roots here. One is negative 7 plus the square root of 181 over 6, and the other one is minus 7 minus the square root of 181 over 6. You can leave the solution just as you see it. Because this is an irrational expression, this is the best and most accurate way to express the roots. In another example, 2x squared plus 3x plus 7 equals 0. From formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, all of which is upon 2a. b is equal to 3. Minus b is equal to minus 3. Followed by 3 squared, which is 9. Minus 4 times 2 is 8, and 7/8 are 56. All divided by 2 times 2, which is 4. This is minus 3 plus or minus the square root of minus 47 divided by 4. Since the square root of negative 47 is not a real number, then there are no real roots. The non-real solution here is often referred to as a complex number. No real roots. b squared minus 4ac the part under the radical sign in the formula is called the discriminant. The kind of roots to expect is determined by this value. 1. If b squared minus 4ac is greater than 0, two unequal real roots occur. Two, if b squared minus 4ac equals 0, two equal real roots occur. If b squared minus 4ac is less than 0, there are no real roots. But what you do get are two unequal complex roots.